Okay, Assalamualaikum and good morning, everyone.
Good morning, sir.
Okay, so today we will discuss on assignments number 2, assignment 2A and 2B. And tomorrow you will have your test 1, okay? So your test 1 will cover topics on ODE, how to solve ODE using MATLAB. Okay, so let's look at assignment 2A first. Okay, so assignment 2A, the production of an acid P from a protein T in a cell involves a two-step process. This involves the production of an enzyme TE via the mRNA transcription from DNA. This enzyme then catalyzes the process of the conversion of T to P. The mathematical model describing these processes are given by the following 6 ordinary differential equations. So there are 6 equations. In these equations, T0 and Ti represent the concentrations of protein T outside and inside the cell respectively, while the other terms are model parameters as listed in table 1. So table 1, there are a number of parameters with their values. So question A, simulate the model using initial conditions with time range given. Okay, so the first thing that you need to do is you need to write the function that contains the ODE equations. Okay, so we can start by writing function dy dt equals so maybe we name it assignment 1, assignment 2, assignment 2A, which has input t and y. Okay, so we start with writing a zeros, okay? A 0 for dy dt. So we have 6 ODE. So we start by writing zeros. I think it's 6, 1. Okay, then we can write the equations for the ODE. Okay, so to avoid confusion, maybe you can name it, let's say DNA. No, dy dt1 is DNA. mRNA, so the dy dt2 is mRNA. dy dt3 is TE. dy dt4 is T0. dy dt5 is Ti. And lastly, dy dt6 is T. Then we can write the ODE. So we start by writing the first ODE. So dy dt1 equals 0. And then dy dt2 equals A1 times, so DNA is represent Y1, okay? So you just write Y1 minus K2 times mRNA. mRNA is Y number 2. And then the third one, K3 times mRNA Y2 and K4 times TE. So TE Y3. And then dy dt4, we have negative V cell over V out multiplied by, so we have KT1 times PT times T0. So T0 is Y number 4 divided by KD1 plus T0. So T0 again Y number 4. Okay, so make sure you put everything in bracket correctly, okay? And then equation number 5. We have similar terms here. So I prefer to just copy paste. Then minus. We have KT2 times TE. So TE is Y number 3. And then TI, Y number 5. And divided by AB2 plus TI, Y number 5. And then lastly, we have bracket B cell divided by cell plus V out multiplied by similar terms. We just copy and paste. So if you don't have any red lines underneath, then all equations should be correct. Okay. Now after you define, after you write the equations, there are few parameters that you need to define before these equations, like K1, K2, and so on. So all the parameters are given in the table. So you can define the parameters before the equations. So we have K1 equals 0.03, K2 0.0022, K3 K4 and then KB1 KB2 KT1 KT2 KT V cell and V out. Okay, so in the function ODE, for the first function, you must have the zeros. So zeros is just for precaution, okay? Like it will make all the arrays dy dt back to 0. If you don't put this, your code will still run, but might produce wrong results, okay? And then after you write the dy dt zeros, then you define your ODE equations in terms of code. And then after that, you define the parameters. Okay, so make sure your parameters are similar in the ODE equations. So let's say if you write big K here, let's say big K1, then here also must be big K or capital K. Okay, so make sure all these parameters tally with parameters in the ODE. Okay, so after you write this, then you can write the solver function. So in the question says submit as your matrix number. Okay, so you can write the name here. Let's say Q to A and A 18000. Okay, so just name your function with your question number and matrix number. And when you save, it will automatically save as your matrix number. Okay. So in the solver function, the first thing that you need to write is you need to write the time span. So time span given is from 0 until 86,400. And then why not? Because we have 6 ODE, so we must have 6 why not. So the first value is 0.0377, and then 0, 0, 2000, 29, and 0. And you can write your ODE solver. So just call the ODE function. And then tspan, why not? So we can try solve this first to see whether it's working or not. So when you get y, there are 6 different y's, so your code is correct. Okay, but we are not sure about the results. Maybe it's not correct or not. Okay, so if you manage to write until all this, then you basically answered the first question A. Okay, any questions so far?
Sir, morning. So kalau yang macam ODE function tu di atas, lepas tu macam ODE solver mate tu di bawah, tak ada juga efek kan?
Tak boleh, kena ni kat atas.
Oh, kena solver kat atas lah.
Sebab kita akan run code tu, kita sebenarnya run function yang ni je sebenarnya.
Oh,
So that's why we name kita punya save file ni function yang solver tu. Kita tak save function ni. Ni macam function dalaman lah, kira macam internal function.
oh kita
So
ambil
that's
tu
what
je. Yang atas tu tak.
yang ni kita solve. Nanti dia akan automatic call function yang ODE tu. So kita bila kita run, kita sebenarnya run yang ni. Kita run code ni. Yang assignment dia akan automatic cari dia akan cari dekat mana assignment 2A.
Okay,
So
kalau
yang
yang
ni mesti kat atas. Sorry.
kalau yang
Teruskan.
macam initial condition tu kan, yang tu kita letak macam y0, 1y, 1y, 12, 13, lepas tu kita state dekat bawah dia punya nilai, boleh juga kan?
Boleh buat macam tu juga. Like y1 berapa. Tapi in the end sebenarnya y not mesti combine lah. Y1, Y2, Y3, Y4, Y5, Y6. Dan baru guna
Lepas tu
dalam
kita
ni.
lepas tu kita state dekat ODE equation lah kan, betul? Yang kat parameter tu. Ke kat bawah, dekat bawah
Yang ni,
parameter.
yang initial values kena dalam solver function.
Okay.
So dalam solver function mesti ada time span dengan initial conditions tu. Dia mesti kat sini. Dia bukan dalam ni. Yang dalam ni, yang ni je, parameters dengan ODE.
Okay, doktor. Thank you.
Okay. Okay, so we move on to question B. So question B, plot TE and P against time T in two separate plot using subplot and different colors. And then label all axes and put titles. Okay, so sebelum kita plot, kita kena tahu TE and P. We need to know TE and P is Y number what? Y what, okay? So here we have Y here, that when we solve, we got 6 different values. So we have 6 different Y values. But we must first identify which one is TE and P. Okay, so we actually have defined this here. So TE is Y number 3 and P is Y number 6. So before we plot, it's good to sorry. So what I will do is I write, let's say, TE equals Y. So TE just now number 3 and P equals Y number 6. Okay. So the question asks to plot in subplot. So you can write subplot. First plot. And then 1 by 2 and the first plot. And then plot time versus TE. Maybe color blue. Plot. Plot T versus P, color red. So let's try first. Okay, so we got the plot in subplot separate. So now we need to label the axis and put titles. Okay, so we can add label So X label. So X axis time T. Y axis. So for the first part, it's TE. TE. Oh no, yes. So title TE versus time. So similar for the second plot. It's P versus time. And you can check first. Okay, so we got the plot with title and axis label. Okay. So that's for question B1. And then B2, from the plot, determine the steady state value of TE and the time taken to reach it. Then describe the change in P over time. Write your answer in comment. So this one basically requires you to just look at the graph and analyze the results from graph. Okay. Okay, so from graph, the first question asks for steady state value of TE. So just write steady state value of TE is about 34 to 35. Okay. And then time taken to reach this value is about, so it's somewhere here. So maybe about like 2 seconds. So about 2 times 10 power of 4. About 2 times 10 power of 4 second. Oh, bukan second, 2 times 10 power of 4. Okay, no unit. Okay. And then lastly, describe the change in P over time. So P increases linearly with time. Okay, so this is the answer for question number B2. Okay, so just write your comment in your answer in comment. Okay, in the code, but in comment. Okay, any question?
Sir.
Hmm.
Yang TE tu kan, yang TE tu yang
Tengah makan dulu.
naik yang makan yang TE tu yang equal to Y, lepas tu yang mana yang bawah tu, yang dekat label tu, dekat atas. Yang ni dari equation kan yang nombor 3 tu.
Sebab kita define TE Y3. So kita guna Y3 as TE lah. Kita define tadi.
Yang okay. Thank you.
Okay, so we go to question C pula. So question C, the cell is contaminated with molecules that inhibit the protein transporter. Simulate the model for this case by writing a new code using the same initial conditions and time range in A. So apa yang perlu buat? Just copy and paste. Then change the title to question C and save. Okay, save dulu. Then we do the modification. So the modification says the question says the cell is contaminated with molecules that inhibit protein transporter. So what basically you need to do is you need to adjust one of the parameters to replicate the condition when the protein transporter is inhibited. So when the protein transporter is inhibited, basically it will not function. Okay, so it will not function. Then maybe the value of the parameters become 0. So if you look at protein transporter, so if you look at the parameters, there are a number of things, a number of parameters that you can modify, but you need to modify the one related to protein transporter. So we have Michaelis constant for protein transporter, KB1, and we also have protein transporter concentration, PT. So which one you need to modify? So if
PT sir.
PT betul. But sometimes in test you modify KB1, okay, or you modify PT. Maybe you modify KB1. This is like sort of like open-ended. Okay, if you modify KB1, maybe you get 7 marks out of 8. But the way you comment later will be taken into consideration, still taken into consideration. But if you modify, let's say K1 for example, salah, not K1. So it's either KB1 or PT. So it's actually PT because PT is the number of protein transporter on the cell, while KB1 is the constant of Michaelis constant is something like related to the chemical reactions occurring in the transporter. So the cells basically stops the protein, okay, stops the protein from functioning. So it basically something like remove the protein from the cell, something like that. Okay, so the concentration will become 0. So what you need to do in this question is just modify this value PT. So maybe you put comment here, this original value. So the new value is PT equals 0. So you modify PT to replicate this process. And then just repeat the process in B. So you just run the code. Okay. And we get some results. And then process in B, you also need to determine the steady state value of TE and so on. So steady state of TE is the same, about 34, 35. The time taken is also the same. So you can just state steady state value and the time taken. Are same as question A. However, for P, so the question B and C number 2 is basically the same thing. So for P, it increases with time until about 0.1 until about 0.1 times 10 power of 4 time and reaching a steady state value about 0.12 to 0.14. Okay. So the effect of contaminant, question C2. Contaminant. It does not affect PE, but it stops the function, the production P. Bangun tidur. Stops the production of P at time 0.1. Apa-apa je lah. Okay. So the effect of the contaminant, basically it doesn't affect TE, but it affects P by causing these changes lah. Okay. Basically it stops the production of PE at time 0.1, and the production of P stops until about 0.12 until 0.14. But if you compare to question A, P is increases with time. So P keeps producing. So the cell keep producing P, even though as if like nothing happened. Okay, so P is keep on produce, while if there is a contaminant, so P stops being produced at time 0.1, and it doesn't affect TE. So TE maintains the same thing as previous, compared to previous without contaminant. Okay. So explain lah sepanjang boleh, letak lah macam mana pun. But if you got the points, the necessary points, then you get the marks. Okay. Okay, any questions before we move on to the next assignment?
Sir,
Yep.
kalau protein transporter tu modify dua protein transporter tu masih acceptable ke, atau yang tu memang salah?
Yang mana? Kalau modify KB1?
Kalau modify KB1 dengan PT
PT
tu sekali, dua-dua sekali.
Boleh je. Mungkin markah dia tak full lah, maybe 7 macam tu lah. Tapi in the end, saya tengok plot, then tengok komen ni, and then tengok yang ni juga. Kadang-kadang student dia plot semua, dia dah modify dia plot, and then komen ni dia tak tukar, just dia copy from the question A. So kalau tukar ni ada points lah, kalau tak tukar ni mungkin separuh je lah, 3 markah ke macam tu lah. Just marks for modification.
Okay sir, thank you.
Okay. Okay, so let's look at question B. Question 2B. Okay, so a heart muscle excitation model has the following system of ordinary differential equation. Okay, so there are two ODE. So V and W represent the membrane voltage and the fraction of potassium gate that opens. So further, the gating parameters MI and WI are described using the following sigmoidal functions. Okay. So the other terms are model parameters. So table 1 contains the model parameters. So question A, simulate the model using initial conditions V0 and W0 with time range. So So first step is to write the ODE. Okay, so we begin with writing the zeros. And then defining the ODE first. So first one, dy dt1. So 1 over c multiplied by dca times mi times p by 1 times ECA minus v by 1 plus gk times w times ek minus b. So v is y1 plus g leak times e leak minus v plus I steam Okay, and then the second one, 0.04 Wi minus W is Y2 divided by EW. Then we need to define the sigmoidal functions. So the first one is MI 0.5 times 1 plus tangent H. So V is Y1 minus VM over M. And then WI. So it's almost similar. Just copy. And then this is theta W and VW. Okay. Then we define the parameters. So we have PK, PCA, ELIC, EM, PW, theta M, in theta W, GK, ECA, ELIC, stance W, Okay, so we have defined everything. Then we can write the solver function. So QA so we write the time span first. So from 0 to 1500, then y naught is -35 and 0.0149. Then we write the ODE solver. Then we can save it. Okay. Okay, and then we can try run in command window. Okay. Damn. Oh, ni W. So W is Y2. And we get 2Y. So you have two different OD. So you have 2Y. So your code should work, okay? Then this is for question A. So for question B, plot V against time, label all axes. So similar to assignment 2A. So we split the Y first. So Y1 is V and Y2 is W. Then plot V against time, label title. And you can run this code. So we get the graph here. So this is our action potential for one cycle only. So it's actually repeating, but the equation given is only for one cycle of action potential. Okay, then question B number 2. From the plot, determine the maximum value of V. And then steady state value of V and the time taken to reach the steady state value. So XV is about -5 or -4. And then steady state value of B. So it's somewhere here. So about negative 15. So this is negative 6. 15 to negative 40. And time taken to reach steady state value is about maybe here 1000. Okay. Now we can go to question number C. Question C. So a heart is given a drug that blocks all of the calcium gates. Simulate the model by writing new code using same initial condition and time range. Okay, so just copy, paste, and then change the title, save, and then modify the parameters to replicate the condition when calcium gates is blocked. So we need to modify something here. So when calcium gates is blocked, so we can modify calcium gate conductance equals 0. So maybe we put here, comment here. Okay, so we modify this value. Then we run the code. Okay, so we get a new action potential. And then we can write the based on question number B number 2. So the maximum value now increased to about 9 to 10. And steady state value is about same. And then the time taken to reach steady state value maybe slightly earlier. And then question C1, C number 2, the effect of drug. Effect of drugs. Increase V. Does not change steady state V. But the steady state V is reached faster than without drugs. Okay. Any question before we end this lecture? Nak tanya apa? Okay, so your test tomorrow will start at 8 a.m. I will post the question and submission link in Kalam. So the question is only one question about ODE. Itulah dia. And then the time is 1 hour 45 minutes. And 15 minutes for submission. So 2 hours overall. So submit before 10 a.m. If you submit later than 10 a.m., for every 1 minute late, 1 mark will be deducted from your test final marks. Okay. It's real. I will do it. Tanyalah yang dah ambil. So please submit early so that you don't lose marks because late submission. And I know tomorrow maybe a lot of things will happen, like kalam down lah, internet tak ada lah. Tak kira, dikira tolak markah juga. Okay, so I hope you can do the question tomorrow. Question tomorrow agak mudah lah, okay? Tapi dia memenatkan. Itu je clue dia. Okay, any question before we end this lectures?
I guess no, sir.
Okay, so thank you very much and see you. Actually, I want to brief project, but next week lah. Okay, so you'll see you next week. I will brief you about the project also next week. Thank you. And also, starting next week, we are going to use COMSOL Multiphysics. So try to get COMSOL Multiphysics, okay?
Okay,
Assalamualaikum.
okay.
Assalamualaikum and goodbye.
Thank you, Doctor.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, Doctor.
Bye.
Bye.
Thank you, sir.
Thank
Okay,
you.
Doctor. Okay, Doctor.
Bye. Assalamualaikum. George pula. Assalamualaikum. Bye.
Waalaikumsalam.
Okay lah, George.
Okay, bos. Okay.
Lari dah Stephanie.
Baru. Okay.
George 10:30 meeting.
Apa, saya mandi dulu ni, Doktor. Hujan ni.
Okay.
Hujan dah basah.
Hujan. Tidur.
Dah.
Okay.
Bye. Assalamualaikum.
Assalamualaikum.